This is Unit 8, Video 3, Equilibrium. So equilibrium, in nature, things want to get towards equilibrium. They want to balance things out. So what equilibrium actually means is that the rate of our forward reaction is going to be equal to our reverse reaction. So that means if we start with reactants and we're producing products, eventually we're going to consume we're not going to have as many reactants anymore because we're using those reactants, because remember, reactions are just simply the rearrangement of atoms, so we're rearranging them to produce products. But what's going to happen is we're going to have lots of products now. So eventually those products are going to start colliding with each other, and what's going to happen is we're going to reverse back to the reactants. So when that rate of going forward and going back is equal, we're going to call that equilibrium. Okay, so we can do a calculation for equilibrium, and what we call it is the equilibrium constant. Now, it's key when we're doing equilibrium constants that we're only dealing with things that are in the aqueous or the gas state. Solids and liquids don't have an effect on the equilibrium constant. So here we've got a reaction. We're taking iron chloride and solid aluminum, and we're reacting it with aluminum chloride and solid iron. So, and if we were to determine the equilibrium constant is represented by a K, and it's normally K of equilibrium, or you can also see it as K as C. And C is just meaning the change in concentrations. Okay, so if we were to do this, the way you were to write the equilibrium constants is it's going to be the concentration of products raised to the power of the products divided by the concentration of the reactants raised to the power of the reactants. So what that means is if we were to do products over reactants, so let's look at our products first. Okay, well, iron here is a solid, so it's not going to matter. So we're not going to calculate this into our equilibrium constant. Here we've got aluminum chloride. So we're going to have the concentration of aluminum chloride, and we have to raise it to the power of how many we have. We have 2, so this is going to be a square. Okay, now if we were to look at the reactants, okay, here aluminum is a solid, so it's not going to be involved in the equilibrium constant, but iron chloride is aqueous, so it is going to be involved. So we're going to have iron chloride in the bottom. Okay, and we've got 3 iron chlorides, so this is going to be a cubed compound. So remember, this here is concentrations. So we would need the concentration of aluminum chloride and the concentration of iron chloride. Okay, if we go over here, we've got another reaction in which everything's in the gas state. So all of this is going to be involved in calculating the equilibrium constant. Okay, so if we do the equilibrium constant, I'm just going to use KVQ equals, it's going to be the products over the reactants. So our product here, okay, and we have 2 of those. So if we have 2 of those, we've got to square it. Okay, now if we look at our reactants, on the bottom, our first reactant, concentration, we've got 2 of them, so we've got to square it. Now the key here is we're not going to add these together if you've got more than one product or more than one reactant. They're going to be multiplied together. So now we're going to have the concentration of chlorine. Okay, now don't put that we have 2 chlorines. We only have 1 chlorine, so it's only raised to the power of 1. And once again, remember that this is representing our concentration of our product, concentration of our reactants. They have to be either aqueous or gas to be used in the equilibrium constant.